Hello guys, you're welcome back to lesson 4 and we are still talking about statistical tests analysis. So let's go back to the PowerPoint slide and see, okay, we talked about t-test. So as an improvement on t-test, we have the ANOVA analysis of variance, which is also a for test of mean differences between factors. Alright. So when we're doing the t-test, doing the independent sample test, yeah, independent sample, we said that when we have two factors in a variable, when we are testing their differences uh, on a continuous variable, or the difference of a continuous variable among them, then we use, when they are just two factors, we use the independent sample test. But once the factors are more than two, if they are three, then you use one-way ANOVA. You can also use two, when they are two, you can also use one-way ANOVA. Um, from two, three upward, you can use one-way ANOVA. But when you have not just one variable with the factors, you have like sex has male and female, one, and um, you have income, no, not income, no. Let me see. We have, okay, employment status, occupation, also, which has levels. Well, and you are testing it on income. Is there, what we are testing is, are there main differences, or are there significant main differences between these factors? The factors here are employed, retired, students, the levels. They can also be called, the factors can also be called levels. Then, are there main difference between male, the income of male and female? Are there main differences, significant main differences between employed and retired, students and all? And then two, we also test, it doesn't just test for V1 and V2, also test difference between V1 and V2. The main difference between them, is it significant? Alright, let's go straight to work. So analyze to start the one-way ANOVA. Now compare the one-way ANOVA. So I'm going to set this. So my dependent list is my income and my independent is sex. Okay, let me use occupation. Occupation and contrast, really I don't have any business here. And post hoc breaks it down for you. Now, which post hoc to use largely depends on you and where you're submitting or where you're working for. It largely depends on them. So for sake of easy interpretation, I like to key test and continue. So the post hoc test further buttresses your results, helps you to break it down more. Then okay, that's for the one way ANOVA. Alright, so this is my ANOVA table. It's very short. So my between groups, within groups, degree of freedom, mean square, my F, then my significance value is a p-value telling me not to accept, no, to accept the null hypothesis, which states that there is no significant main difference between the levels of occupation, levels of occupation as student, employed, blah blah blah. So that the income across this is not significant. The main difference between these levels of occupation is not significant when you talk of their income. So now this is a Tukey HSE test. Now it buttresses the results gotten here. Here we've identified that the main difference of the income of these occupations, the incomes this occupation have, they are they are really not different. All right. So here the two key tests brings them out. You know, we have students as a level, unemployed as a level. So what's the significant difference between student and unemployed? says here that it's still not significant because the significant value is 1. That's very not significant, not even different at all. So, student unemployed, also very not significant. So, by the time you check everything, it tells you it's not significant. Sometimes you have results that are significant. And I need to just mention this here that a lot of people do approach analysis with they feel there's a particular result they should have. That your result is not significant is also a result. That there is no mean difference is also a result. That there is no impact is a result. Everything does not have, you don't have to accept, you don't have to reject hypothesis all the time. Whatever output you have is what is obtainable. Is what is obtainable. All right, that's for one way and over. For two-way and over, come back to analyze. So now compare with obviously don't have any other. So come to general linear model, univariate, and of course, okay, I have the income here, still the dependent variable. Then my fixed factors are the sex of staff and the occupation also. Post hoc, still tricky. So now I told you to do post hoc for only V2 because V1 does not have up to three levels. That's just two. That's sex, male and female. So it wouldn't, whatever result it has for V1 is the same. So there's no need to break it down in the two key tests and it wouldn't do it. So that's why I leave that there. Then okay. So here again I have my V2 here, not significant. V1 not significant. V2 by V1, between V2 and V1, not significant. Then if you break it down, you have the same results you had earlier on for one way ANOVA. Alright, so that's a quick one on ANOVA, one way and two way ANOVA. I'll still focus on we are training focusing on experimental design where we can go more into the analysis of experimental designs. But for now, the scope of this training, the intermediate course, uh, focus on one way and two way and over. All right, thank you very much.